No, it's actually a mole. This is the first time I have ever seen a mole in real life. I've seen for mole. So it's what we use to represent particles, either atoms, molecules, formula units, and so forth. So what is a mole? I want you to write down one word. A mole is a quantity. And you understand quantities because you grew up with the dozen. You grew up with other quantities. So just like a dozen means 12 of something, a mole is going to represent a certain number of things. It's just going to apply to particles. So you understand dozens. If you were converting back and forth between donuts and dozens, you would be using these conversion factors. You either multiply by 12 or divide by 12, and you know how to do that. Other quantities that you may know and use in everyday life would be a ream, 500 sheets, or a million. So you understand quantity. Now let's understand the mole. This is a mole. Not really the mole in chemistry, but I have to tell you, I was so excited. I was running one day recently and I saw one on the sidewalk. I thought it was a mouse, and so I stopped, took a picture, and I was like, oh no, it's actually a mole. This is the first time I have ever seen a mole in real life. I've seen them in chemistry books, and I thought maybe it's just a mythical creature. But the mole actually exists. I saw one. I thought that they would be really large. From the pictures in the book, they look large. This little guy was about 4 inches long. And let's just say he's taking a nap on the sidewalk. Not really. But I thought it was cute, and I wanted to show you that moles are real, and he's got big digging hands, and I thought he was really cute. But all right, let's move on to a mole in chemistry. It's just a quantity. It's a big quantity because we need the ability to count out particles in chemistry, like atoms or molecules. So here is the mole. Now, the abbreviation for mole is MOL. I know, it's kind of silly. We just drop one letter, but that is the abbreviation for mole. So it's what we use to represent particles, either atoms, molecules, formula units, and so forth. So here is the number. It's called Avogadro's number. This is Avogadro, and it is 6.02 times 10 to the 23rd. It is a huge number. I want you to imagine that number written out in longhand. How many zeros are there? It's just huge. Why is it such a big number? Because particles are so small. If we dealt with dozens of atoms, it wouldn't even make sense. It's just too small of a quantity. So because these particles are so small, we have this huge particle that's going to help us count out and measure out these units. Now, in the next video, I'm going to teach you how to convert between moles and particles.